In this video, we'll use factorial and double factorial to generate the Taylor-Maclaurin series sum of the square root of 2 pi times phi sub x. We begin with the formula of the expansion, which is the summation of a times 2 times x to the power 2n, where the value of a can be factorial, which is a1, or double factorial, which is a2. And the value of n is from 0 to infinity. So we can go as far as 16, which is good enough. We continue with the double factorial. So r formula minus 1 raised to the power n divided by, that's double factorial. So fact double 2 times n. And enter. And we continue with the factorial coefficient. So r formula minus 1 raised to the power n divided by, there are two parts. So the first part is factorial n, factorial of n. The second part, 2 raised to the power n. And enter. Now we can complete the expansion, which is r formula, series sum of the x values raised to the power 2n. 2n starts from that n equals 0, 0. Then followed by 2, 4, 6, 8, so the interval is 2. And the coefficient, you can choose factorial or the double factorial or factorial. Start with the double factorial. And the phi function. So r formula, let's start with the phi function. Phi of x. And we chart this. Insert chart. And we use scatter chart. Use column A as label. We don't need a title because we're going to use the equation as a label. So customize series, trend line, show the trend line, polynomial to the 8th degree. And for the label, use the equation. For the legend, position at the bottom. So here's the trend line and polynomial to the 8th degree. We'll calculate the polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 8. And the elements of the matrix. So R formula of the x values raised to the power 0 to 8. And the polynomial regression coefficient, LINEST, data y, and data x. That's for the expansion. Continue with the function, LINEST, data y, comma, and data x. And we modify the phi function. So here we have the phi function. We factor in square root of 2 pi. So that is times square root of pi. That's square root of pi. Square root of pi. And 2 pi. That's 2 pi. Square root of 2 pi. Now they're exactly the same. We compare with the coefficients, that is the coefficient of x to the 0, that's 1. Coefficient of x, 0. Coefficient of x squared, minus 0.5. Coefficient of x cubed, 0. Coefficient of x to the 4th, 0.123. Coefficient of x to the 5th, 0. Coefficient of x to the 6th, negative 0.0182. Coefficient of x to the 7th, 0. Coefficient of x to the 8th, that is 1.23 times 10 to the minus 3. That's because in the expansion we use the double factorial. Suppose we use the factorial. So use the factorial and enter. We still get the same polynomial regression coefficients. Our polynomials remain the same. The trend lines are the same. And the datasets are still the same. This completes the use of double factorial and factorial in generating the Taylor-Maclaurin series of expansion of square root of 2 pi times phi sub x, phi of x.